Hello everyone, I'm Nathan Yellen from Team HealthBoost for the Anthem Hackathon. The problem that we chose to look at is mental health hospitalizations and rehospitalizations among patients with schizophrenia. This is a huge problem, especially for patients with schizophrenia, which are more likely than other mental health patients to be hospitalized. There are a lot of other studies that have been done in the past that found that actually many of these hospitalizations can be prevented with appropriate community care. Not only that, but once someone has been hospitalized for schizophrenia, if you provide them appropriate care once they've been released from the hospital, you can dramatically decrease the chance of future hospitalization. Therefore, we chose to focus on this problem and to look at ways to detect very early on that someone is undergoing an event which can increase the chance of their hospitalization. If you can detect that early, you can intervene, you can prevent that hospitalization. Obviously, this problem is really a more general problem, and because we look primarily at the claims data, then this is a problem that you can generalize to many other diseases using very similar algorithms. Our system has several parts. First of all, we have on the data side a machine learning model that looks at the patient behavior, learns what is usual, and then scans 2-month intervals for each patient and predicts the chance of a hospitalization in the next 60 days. Next, we have a live data dashboard for the front end, which shows you the data about all the different patients so that medical professionals like doctors can look at data about the patient in front of them and analyze using that support system how likely a patient is to be hospitalized or not. Finally, that same system has a back end which can run various algorithms and which can then detect when a patient crosses a critical threshold in terms of their hospitalization risk, and we can then send out push notifications to their doctor to let them know that something is going on and that they should check in with that patient and see if there's anything they can do to help them before they're hospitalized. On the algorithmic side, one of the main problems that we had here was that we don't really have a classic classification problem. The claims data has data about different claims. For example, maybe it has data about 10 different doctor visits, and each doctor visit in and of itself doesn't really have a lot of predictive power. What we did in order to solve that problem is we took all those different doctor visits over a 60-day period, and then we summarized that, and we showed the number of doctor visits for each type of doctor visit, and for each location where they visited a doctor. We then took those summarized periods and we entered each one as a single data point. So for every patient, we have one data point for every 60-day period with a summary of their behavior over the past 60-day period. Then we look 60 days into the future and we see whether they were hospitalized in the next 60 days or not. And now we have a classic classification problem where we want to take those 60-day intervals for each patient and we want to predict the likelihood that they'll be hospitalized in the next 60 days. Obviously, this is easily parallelizable, and most of the computational work here is done on preparing the MCIDs, going over each patient and preparing their time series data, and that can be easily parallelized when you split by MCID. For the machine learning algorithm, we did grid search over hyperparameters, over KNN, random forest, and logistic regression. We found that we got the best results for random forests. We'll look at the results for that very shortly. For the front end, we built a real-time dashboard using Angular event stream and NG charts. We display there all the data for all the patients. We prioritize it by the risk. We update it when new events come in, and we support sending out push notifications. Here's a very brief summary of the data on schizophrenic patients that you can see from the claims data. You see here 2 patterns which are very well known for patients with schizophrenia. First of all, that hospitalizations are extremely common and occurring well over half the cases. And second of all, that schizophrenia is more common with male than female patients, and that there's a spike in the 20s. Here are our results. As you can see, the most important features were doctor visits of certain kinds and whether a patient was hospitalized in the past or not. Here's a brief overview of our architecture, which runs in the cloud. For the future, we really would like to take this and expand this, and the main thing that we wanted to do was to improve the predictive power by looking at time series pharmaceutical data. For example, to look at whether someone has suddenly stopped taking their medications or not. Here's a demo of our system. You can see here the Vive dashboard. You can see here that events come in, and we update the risk for each patient as those events come in. Here's our team. I see that we've run out of time, so I'll just say briefly that we have 2 data scientists, Achinoam Soroka and Idan Shachmun. I, Natan Yan, worked on the data preparation, and the entire front end was built by Liran Nachman. We hope that we can work on this in the future and take it forward and build a system here that can be widely used and make a big impact. Please send us your questions.